Hello, so this now is for cosine theta, which is equal to c. Now our principal value and secondary value, they both occur in the period 2 pi. And the general solution to cosine, so the general solution to cosine theta equal to c, where the modulus of c, again less than or equal to 1. This is calculated by adding multiples of 2 pi. So by adding multiples of 2 pi to either the principal value or the secondary value. And that's simply because of this relationship that secondary value is equal to -1 times the principal value. So the general solution of cosine theta equal to c can be written as theta is equal to plus or minus PV at 2n pi, where n belongs to a set of integers. And that's it for the cosine ratio. Thanks for watching this video. My name is Alistair. Bye for now. Hello. So this is for the ratio tan theta is equal to t. And t, the principal value in this interval, so the principal value PV in minus pi over 2 to pi over 2 lies completely in this period. So angles with the same tangent ratio can be calculated by a combination of multiples, calculated by adding a combination of multiples of pi. So the general solution, is theta is equal to principal value add a multiple of pi. Again, where n belongs to a set of integers. Pi being 180 degrees, so alternatively you could use the formula with degrees, and then that would be principal value add 180n. Likewise for sine and cosine general solution formulas. And that's it for the three trig ratios. Thanks for watching this video. My name is Alistair, and I'll see you on the next one. Bye for now. Hello. A few questions now on finding the general solution of equations. First, we have tan theta equal to root 3. The principal solution of tan theta equal to root 3 is simply theta equal to pi over 3. So if you do tan inverse of root 3, we'll get pi over 3, or 60 degrees. So using our formula, the general solution and you would have seen this if you looked at my previous videos published last night. So the general solution is pi over 3, and we had a multiple of pi, and where n belongs to a set of integers. I urge you to substitute values of n and to confirm for yourself whether this infinite set of angles satisfy the equation tan theta is equal to root 3. Always check your work. It's a very useful thing to do, especially in mathematics. Next we have tan theta is equal to 1 over root 3, or the reciprocal of root 3, or the principal solution is again pi over 3. Sorry, not pi over 3, but pi over 6. So our general solution is theta pi over 6 and multiple of pi, where n belongs to a set of integers. Again, check for various positive and negative values of n to ensure that whatever you arrive at as theta, if you find tan of that angle, you should get the reciprocal of root 3. Thanks for watching this video. I'll be doing a few more examples in the next few videos. Bye for now. Here we have to find the general solution set of the equation sine theta is equal to 1/2. So the principal value or principal solution, let's use the word solution because we're using that analysis, for theta where we have sine theta is equal to 1/2 is pi over 6. We also have a secondary value which lies within the restricted domain, and that's 5 pi over 6. So our general solution is 2 parts. Theta is equal to pi over 6 at 2n pi, and theta equal to 5 pi over 6 at 2n pi. And that's it for sine theta equal to half. Thanks for watching this video. My name is Alistair, and I'll see you on the next set of videos. Bye for now. Hello there again. Find the general solution of the equations cosine theta equal to root 3 over 2 and cosine theta equal to a half. Or for cosine theta, the principal solution and that's when theta is equal to root 3 over 2 is pi over 6. So cosine inverse of root 3 over 2 gives us pi over 6. So the general solution is theta equal to plus or minus pi over 6 and 2n pi. And just if you're wondering why we have plus and minus, remember this relationship between secondary value and the principal value. Opposite in size, in signs, the same in the value. Now we have cosine theta is equal to a half. So for cosine theta equal to a half, we have the principal solution of theta is pi over 3. So a general solution theta is equal to plus or minus pi over 3 at 2n pi, where n belongs to a set of integers. This also goes to this, n small n belongs to a set of integers. Please check your results using different values of n to confirm that theta satisfy each of these equations. Thanks for watching. My name is Alistair, and I'll see you on the next video. Bye for now. Hello, here's a problem I tackled yesterday and published it on my channel. The result was the principal value being pi over 6 and the secondary value being 5 pi over 6, and the results were produced as theta is equal to pi over 6 at 2n pi and theta 5 pi over 6 at 2n pi, where n belongs to the set of integers. Well, here's a more compact way of bringing together both of these results. When sine theta is equal to a half, we can write that theta is equal to minus 1 raised to the n power pi over 6. So we're using the principal value at n pi, where n is belongs to the set of integers. And in general, whenever sine theta is equal to s, we can write that theta is equal to minus 1, and we use the principal value n pi. Now, just to explain how this works, minus 1 brackets to the n power. For odd values of n, this will be negative. If you check odd values of n through, let's say, pi over 6, with n being starting with 1 or 3, 5, you'll have a negative result, and this will take care of that negative result. So when this is odd, this will be negative, and this also will be negative, which will give you a positive result. When it's even, when n is even, then this will give you a positive result, which is as expected. So this is a compact way of writing in general whenever you have sine theta equal to s, this equation. Theta can be written as minus 1 raised to the n. Use just the principal value at n pi, where n belongs to the set of integers. Thanks for watching this video. My name is Alistair, and I'll see you in the next one. Bye for now. Hello. Let's continue completing this problem. So when we factorize this, we had 3 sine theta add 2, let's see, 4 tan theta add 3 equal to 0. Now we'll tackle this part of it. So we have 4 tan theta is equal to, add 3 is equal to 0, which implies that tan theta is equal to minus 3 over 4. Tan inverse of that will give us minus 36.87. So our principal solution is theta equal to minus 36.87 degrees. So our general solution, note that we don't use the secondary value for the tan theta ratio. So we can go straight now to find our general solution. Is theta equal to minus 36.87 degrees at 180 n degrees. Alternatively, if we wanted to write a general solution for the whole problem, we could write it in a compact way where theta, we can write theta and include the solutions for sine theta. So we have first minus 41.81 degrees, 360 n degrees. And we have minus 138.41 degrees and 360 n degrees. And lastly, minus 36.87 degrees. This is for tan theta. It's 180 degrees. And here's your general solution in a compact form, which applies to the whole equation. Thanks for watching this video. My name is Alistair, and I'll see you on the next set of videos. Bye for now. Hello. Find the general solution of this equation. I'll do this in two parts. So this first video will be to find sine theta, and in the second it'll be tan theta. First, this looks a bit complicated, so one of the approaches we take in maths is to always simplify everything before you actually start to work. So we have 3 sine theta for tan theta at 3. But here we can factorize this by having 2 out here to make this 4 tan theta at 3. This is equal to 0. Now we have 4 tan theta add 3 is common to 3 sine theta and also 2. So now we can use brackets here. Have 3 sine theta add 2. That's 4 tan theta add 3 is equal to 0. So it's either that 3 sine theta add 2 is equal to 0, which implies that sine theta is equal to minus 2 over 3, or we have 4 tan theta add 3 is equal to 0, which implies that tan theta is equal to minus 3 over 4. So in this video I'll tackle sine theta equal to minus 2 over 3, and the next video will tackle tan theta is equal to minus 3 over 4. So using a calculator you can find the sine inverse of minus 2 over 3, and you'll get that your principal solution is theta is equal to minus 41.81 degrees. And your secondary value or secondary solution is equal to minus 138.19 degrees. Right, this is secondary value. So our general solution for these, the general solution you can just write it curly brackets as theta is equal to minus 41.81 degrees. Notice we're not using radians here because our result is in degrees, so we'll write our general solution using degrees. .81 degrees at 360 degrees, and theta equal to minus 138.41 degrees at 360 degrees. And that's it for sine theta. I'll see you on the next video where I'll tackle tan theta. Bye for now. Hi, today's topic is about general solution of trig equations. The general solution, what is it? It's an expression represents angles that satisfy the trig equation. The general solution is also, we can describe as an infinite set of angles. We can summarize that by saying the general solution is an expression of the infinite set of angles. Now, to come up with the general solution of a trig equation, we need to use the circular function graphs. The period of each circular function, that's very important. The principal solution, let's put that principal and secondary solution. It is slightly different for the tan ratio. In that case, you'd use the secondary solution. For the sine and the cosine, you use the principal solution. Now let's look at the sine wave. So we have that sine theta is equal to s, where we have that s, the modulus of s, is less than or equal to 1. S is just this measurement here on the graph. Now, for the sine wave, the period is 2 pi. So any corresponding point on the wave to another corresponding point on the wave is a period of 2 pi. So we have the period is 2 pi. It's covered by the interval, minus pi to pi. Now, our principal value and secondary value of theta, so principal value and secondary value of theta, lies in this interval. As you can see on the diagram, or on the graph in fact. Now in order for us to find the general solution, we just need to add or subtract any multiple of 2 pi. Okay, we'll write it out of space this. subtract any multiples of 2 pi. And that would be to the PV or the SV. And the general solution is now, we can write this as theta is equal to, we have PV, and we can add 2n pi to get our general solution, and the SV we add 2n pi, where n belongs to the set of integers. So this covers what we've mentioned here of adding or subtracting any multiple of 2 pi to the principal value or the secondary value. So here, for the principal value, we have a multiple of 2 pi, and that's n, which is the multiple. And likewise for the secondary value. And that's it for the sine wave. I'll see you in the next video where I'll cover the cosine wave. Bye for now.